after you've done the bell work, you can check your answers. We're going to be multiplying and dividing rational expressions today. We're going to do 3 different examples that are like each one of these from the bell work. So pause the video, and then when you're ready, you can check your answers. So you should get 3 over 13 for the first one. All I did was notice that they had a 5 in common. So 5 goes into 15 3 times, and 5 goes into 65 13 times. If you're multiplying fractions, you just multiply straight across. So 4 times 8 is 32. 4 times 9 is 45. If you could reduce that, you would, but 32 and 45 don't have anything in common, so you'll just leave it. The last one, we're dividing by fractions, so you need to rewrite it as multiplying by the reciprocal. Then it's just like the last example where we multiply straight across, and then here we should reduce. So your final answer is 7 over 20. 3 goes into 21 7 times, 3 goes into 60 20 times. All right, so we're going to simplify rational expressions, which will be like the first example from the bell work, multiply rational expressions, which is the second thing from the bell work, and then divide, which is the last one. All right, so for simplifying rational expressions, you can have no like terms in the numerator and the denominator. So if there's something that's the same, you need to cancel it out. So in the first example, 4 times x plus 3 over x minus 5 over x plus 3. Notice there's a common factor. X plus 3 is in the numerator and in the denominator. X plus 3 divided by x plus 3 is 1, so they just cancel out. So your answer is 4 over x minus 5. So that's an example where it's already factored for you. A lot of times you have to factor it yourself. So in this example, we have a quadratic divided by a quadratic. That's the rational expression we're given. We need to factor both of them. So in the numerator, factors of 16 that add to -8 are -4 and -4. And in the denominator, factors of -12 that add to 2 are 6 and -4. So again, we see that there's a like term in the numerator and the denominator. X minus 4 divided by x minus 4 is 1. So we can cancel them out. So your final answer is x minus 4 over x plus 6. That's as simplified as you can get. All right, for this last one, again, we're going to factor the numerator and the denominator. There's a greatest common factor in the numerator. We can pull out an x, and we're left with x plus 7. I'm going to rewrite x squared as x times x, just so that you can see the x in the numerator can cancel out with 1x in the denominator. X divided by x is 1. So your final answer is x plus 7 over x. You cannot cancel out the x squareds at the beginning because you are adding in the numerator. The only reason we can divide out the common factors is because we're multiplying. Okay, so let's try multiplying rational expressions. This is like the second example from the bell work. So take a second, copy down the steps. We're going to start by factoring the numerator and the denominator if you can. Sometimes you won't be able to, and that's fine. You'll skip those 2 steps, then you'll move on to the third one and divide out any common factors that you can. Then you'll multiply and rewrite it in simplest form. So for this first one, if you look at the numerators and the denominators, nothing can be factored. So I'm going to start by multiplying straight across. So we can multiply our like terms. we start with 8 times 7, we got 56. X cubed times x to the 4th is x to the 7th. Y times y cubed is y to the 4th. Same thing in the denominator. 2 times 4 is 8. X doesn't have a like term, so we'll just leave it. And x squared, or y squared times y is y cubed. Now that we've rewritten it as one fraction, we can go through and rewrite and cancel out the like terms. So 56 divided by 8 gives you 7. X to the 7th divided by x is x to the 6th. We subtract the exponents. Y to the 4th divided by y cubed is y. So that's an example where you don't have to factor. Here's an example where we will factor. So I always start and factor everything that I can first. So 2x squared minus 10x has a 2x in common, and I'm left with x minus 5. X squared minus 25, that's a difference of squares, so that's x plus 5 times x minus 5. And on the right, x plus 3 over 2. If you want, you can rewrite it as times x to show you that some x's are going to cancel. So we've got 2x divided by 2x, that's 1. X minus 5 over x minus 5 is 1. So our final simplified answer is x plus 3 over x plus 5 times x. And you can leave it just like that. You don't have to multiply the x through. You know you're done when you have no more like terms in the numerator and the denominator. All right, so this is the last multiplying one, so take a second and factor everything you can. Alright, so once you get it factored, we can start canceling. You can cancel out things if they are right on top of one another in the same rational expression, or you can also cancel out diagonally. Remember, we're multiplying here, so you can cancel if it's in the numerator and the denominator, if it's the same. So we've got an x minus 1 and an x minus 1. If I divide those, I get 1. And then x minus 2, or excuse me, x plus 2 over x plus 2 is also 1. There are no other like terms, so all I'm going to do is multiply the fractions. So I've got x plus 4 times 2x, and x plus 2 times x minus 3. And again, you don't need to multiply through. You can leave it just like that. Last one, dividing rational expressions. This is like number 3 on the bell work. The only difference is step 1. We're going to rewrite by multiplying by the reciprocal. After that, it's exactly like multiplying rational expressions. So after you copy down those steps, try the first example. First thing you should do before you factor is rewrite it as multiplying by the reciprocal. Now we can go through and factor and divide out our common factors. So I'm going to factor out of 5, and I'm left with x minus 4. On the top right, I can factor that into x minus 4 and x minus 2. Bottom right, I can factor out an x. So I notice I have an x in the numerator and in the denominator. X minus 4, x minus 2. So every everything gets canceled out except 4 over 5. So that's your simplest form of that rational expression. All right, this is the last one. Notice the second expression doesn't have a denominator, so if it helps you, you can rewrite it as over 1. So when we go to rewrite it as multiplying by the reciprocal, you're going to leave the first expression alone, and then multiply by 1 over 2x squared plus 5x. All right, on the top left, you have a quadratic that has a coefficient other than 1, which means we need to do a C method. So remember, we multiply a times c. That gives you -10. We're looking for factors of -10 that add to 3. So we're going to do 5 and -2. So you're going to rewrite the middle term as 5x minus 2x and leave a and c alone. Whenever you have 4 terms, you factor by grouping and pull out the common factor. So I'm going to pull out an x here, pull out a -1. So your 2 factors are x minus 1 and 2x plus 5. Bottom right, you can pull out an x, so you're left with 2x plus 5. So I see a common factor, 2x plus 5, in the numerator and the denominator. So we'll multiply now. X minus 1 times 1 is just x minus 1. In the denominator, 6x times x, 6x squared. Alright, and there is your homework. On Friday, we'll do adding and subtracting rational expressions.